During this lesson, we're going to continue working with the Pythagorean theorem. This time, we're going to actually use the Pythagorean theorem when given a hypotenuse in one leg to find the other leg. Again, we're going to review that Pythagoras was the one who said in a right triangle, the sum, again meaning the addition of the squares, meaning we're going to square some stuff, the lengths of the legs is equal to the square of the length of the hypotenuse. So again, what we're saying is leg squared plus leg squared will equal the hypotenuse squared. Every so often, students are scared by story problems, and I just want to kind of talk about this really quickly. It says a 16-foot ladder rests against the side of a house. I think it's a really good idea sometimes just to draw a quick picture. It doesn't have to be anything fancy like this, but I think it's a good idea to draw a really quick picture. As you're reading the problem, try to picture the problem in your mind, but maybe draw a really quick picture just so you can understand and refer back to it. So a 16-foot ladder rests against the side of a house, and the base of the ladder is 4 feet away. So the base of the ladder is here, 16-foot ladder, looks something like this. Again, you should be looking, okay, I'm dealing with right triangles, so where is that right triangle located? And again, I already put this right angle symbol right in here to say that those two lines are going to be perpendicular right there. Approximately how high above the ground is the top of the ladder? Draw a picture of the situation, show all your work, and circle the final answers. Again, I'm going to continue using this formula. I'll just say legs squared plus legs squared equals hypotenuse squared. In this case, you'll notice that I know my hypotenuse is 16 squared. I know one of the legs here is 4 feet, so I'll say 4 squared. And basically, I'm going to be left with one more leg. I'll abbreviate that with just an L squared. So L squared plus 16 is going to equal 256. I'll subtract 16 from both sides in order to isolate my variable. That'll give me L squared equal to 240 on the right side. In order to get the L all by itself, I will square root both sides, and L, rounded to the nearest tenth, should be 15.5 feet. 15.5 feet. So here's the idea here. A lot of students will not know exactly when to square root things. They'll try to square root things ahead of time. What you need to make sure is that you have completely isolated the L. So it's L squared on one side equaling just some number. You need to make sure that it's just one variable on one side squared and one number on the other side, and then you'll take the square root of both sides. Again, we'll probably round to the nearest tenth to make sure that we have, unless we get exact answers, which we'll talk about in a later lesson. We'll look at a few quick examples here. It says to draw a picture for each situation. My situations are all going to look really similar, so I'm just going to draw this picture once. Here's a right triangle. I'm given a hypotenuse to equal 16 meters. I'm given one of my legs to equal 8 meters, and I'll just label the other side L. If you want to continue doing that, I think it's a good idea to at least be able to picture it in your mind. Every right triangle is going to look a little bit different. So just that's one example of what it might look like. And again, this looks like it's going to be the longer side, but it could be, technically less than 8 or a little bit more than 8 as we go along here. It says then find the third side of the right triangle, given that the leg is L and the hypotenuse is H. Show all your work, round your answers to the nearest tenth if necessary. Sometimes we're going to get really nice answers. Sometimes we'll have a little bit of a decimal involved. Again, I'm going to continue using this formula. L squared plus L squared equals H squared. In this case, I have L squared plus 8 squared equals 16 squared. That means L squared plus 64 equals 256. Again, it really helps if I have my perfect squares memorized. I'll subtract 64 from both sides. In this case, L squared will equal 192. At this time, I have my L isolated. I have my constant isolated. I'll just take the square root of both sides. In this case, L will equal 13.9. And again, I look up here to find my units. 13.9 meters. For number 3, again, I'll use the same formula. L squared plus L squared equals H squared. I know that one of my L's is going to be left alone. I have 9 squared. That's going to equal 12 squared. That's L squared plus 81 equals 144. When I subtract 81 from both sides, I'll get 63. I then have my L isolated, so I'll take the square root of both sides. And to the nearest tenth, I'd have 7.9 yards. Number 4, L squared plus L squared equals H squared. My leg squared plus leg squared equals my hypotenuse. In this case, I'm dealing with some decimals. L squared plus 3.5 squared equals 9 squared. That's simply L squared plus, I'll have to use a calculator probably to figure this out, but 12.25 equals 81. I'll subtract 12.25 from both sides, and I'll be left with 68.75. I'll then take the square root of both sides, and when I round to my nearest tenth, L, the leg, will equal 8.3 feet. For number 5, again, I'm using the same formula. Leg squared plus leg squared equals the hypotenuse squared. That's leg squared plus 9 squared equals 10 squared. That's L squared plus 81 equals 100. When I subtract 81 from both sides, all I'm left with is 19. When I take the square root of both sides, L equals 4.4. I need to look up there for my abbreviation, 4.4 miles. And again, it's okay to abbreviate miles with an MI or to write out the word miles. One thing not to do, don't leave it as just M. That usually stands for meters. Number 6, leg squared plus leg squared equals your hypotenuse squared. Again, these are getting to be bigger numbers. Leg squared plus 21 squared, whoops, does not, we'll say equals here, 29 squared. May have to use my calculator in order to sort of figure out what some of these squares are, because these are getting kind of big. 21 squared is 441. 29 squared is 841. When I subtract 441 from both sides, I would get 400. And when I take the square root of both sides, L simply equals 20 inches. Number 7, I'm going to continue using the same formula. Leg squared plus leg squared equals the hypotenuse squared. When I substitute this in, I'd have leg squared plus 13 squared equals 17 squared. Leg squared plus 169 equals 289. When I subtract 169 from both sides, I simply get 120. When I take the square root of both sides, the leg will equal 11.0 centimeters when you round to the nearest tenth. We'll try something a little bit different when we're trying to find the area. It says find the area of each isosceles triangle. Show all your work and round your answers to the nearest tenth. The area formula for a triangle, if you don't remember, area equals 1/2 the base times the height. And so what I'll do is I'll have to find the area of this. The side lengths here are 17 and 17. This base is 16. What I'm looking for is I'm looking for this right triangle. If you notice there's a right triangle right here, what I need to do is I need to isolate and notice that this base is just going to be half of whatever the entire base here is. So if this is 8 and this is 17, I can use the Pythagorean theorem in order to find basically the height of the triangle or just the leg here. So if I use this, leg squared plus leg squared equals the hypotenuse squared. Again, this is going to be 8 squared plus, in this case, the height of the triangle squared equals 17 squared. Again, this is a little confusing because of the variable that's used. It's the height of the triangle, which is technically a leg of the right triangle. So it'll be 64 plus the height of the triangle squared should equal 289. I'll subtract 64 from both sides, and h squared should equal 225. When I take the square root of both sides, the height of the triangle should just equal 15 meters. And that's not my answer. It does say up here that I want to find the area of the isosceles triangle. So again, the area is going to be 1/2 the base, which is actually 16. Be careful with that. A lot of people will just say, hey, I'm looking at just 8. But the entire base of this triangle is 16. And I'll multiply that by the height, which is 15. Half of 16 is 8. 8 times 15 is 120. So I have area equals 120. When it comes to units, I need to remember that lengths of things are going to be one-dimensional. So that'd be like m to the first power, meters to the first power. But area is always two-dimensional. So that's why I square the meters. So that's 120 square meters is my final answer. I'll work out the same process here for number 9. Again, I'll make note that I'm going to use half the base in order to to find the height for my triangle right here. So this is going to be leg squared plus leg squared equals the hypotenuse squared. In this case, I'll have, we'll say leg squared plus 16 squared equals 20 squared, the hypotenuse of my right triangle. That's L squared plus 256 equals 400. When I subtract 256 from both sides, I'll get 144. When I take the square root of both sides, my leg, or the height of the triangle, I guess, equals 12 feet. When I use the area formula, area equals 1/2 base times height. The base, again, remember to use the entire base, which is 32, and use the height, which I found here to be 12 feet. 1/2 of 12 is 1/2 of 32, excuse me, is 16. 16 times 12 is 192, and again, my units will be square feet. Why don't you guys try the last one? I'll give you the answer, and hopefully you'll be able to figure out the area at the very end of this should be 48 square centimeters. Good luck.